In this unit, we're going to study polynomials. In this lesson, we're going to look at area and perimeter calculations, but we're going to use polynomials.
Okay, hi everybody. So in this lesson here, we're going to look at area and perimeter with polynomials. Okay, and I will freely admit that this is perhaps not the most obvious application of polynomials, but when we're working with area and perimeter, it allows us to do some fairly simple operations and yet still give it a bit of a context. Okay, so we're going to use our knowledge of the polynomial operations here to write out expressions for the area and perimeter of shapes. We'll do maybe even a little bit more than just evaluating the area and the perimeter here. So now, before we get into that, we need to make sure that you guys remember what we're talking about here. So first of all, perimeter, okay? Perimeter is going to be the length of the outline of a shape. So we're going to add up all the outer lengths here. Now for a rectangle, that is going to amount to 2 times the length plus 2 times the width. So just got to think about what we're talking about here. Here's our rectangle. Okay, so the length is the same on both sides here. The width is the same on both sides. And so our perimeter, the distance around, will be twice the length plus twice the width. Now, that is a little bit different with a square. And the reason why it's different with a square is because all 4 sides are the same with a square. So we can take a little bit of a shortcut. Okay, instead of adding up, the twice the length, twice the width, well, it's the same thing on every side here. So it's really just going to be 4 times the side length. Now, area, on the other hand, whoops, keep forgetting that can't do that there. Area, on the other hand, is a little bit different. Okay, area is a product. Okay, so area is the product. And for both of them here, we're going to consider that length times width. But for the square, it's going to be a little bit different here. Okay, it's going to be just a little bit different because the sides are all the same here. So whereas for the rectangle, okay, we're talking about length times width, and you can see that even from above here. For the square, that is simply going to be the side length squared because the side length is the length, the side length is the width. Okay, so just bearing in mind those operations, the perimeter is the distance all the way around. And we've got a couple shortcuts there if they're nice, simple shapes. If they're not simple shapes, okay, if they're a little bit more complicated, then we have to add up every side as we go around. That also makes area a little bit more complicated. But yeah, let's take a look at some examples and see how it goes. Okay, so these questions here say, find and simplify an expression for the area. Whoops, sorry, forgot. Got to change to the pen here. For the area and the perimeter of each diagram. Okay, so for this first one, we are dealing with a square. Okay, and I know that we're dealing with a square because of these little lines here that indicate that those are all the same length. So I know that the side length here is x plus 3. So my perimeter, we already know, is going to be 4 times the side length, or 4 times x plus 3. Now, actually, I'm going to clean that up just a little bit. I can make that look a little bit better. Okay, x plus 3. So now, when they say simplified here, they want us to expand this out as much as we can here. So I'm going to distribute that 4 through. So 4 times x plus 4 times 3, which would give us 12. So our perimeter would be 4x plus 12. Our area is going to be the side squared, okay? Side squared. So this is going to be x plus 3 squared. Now, there is a distinct danger here of people inadvertently applying that square incorrectly. So I'm just going to show you something that people do wrong here. Frequently, I'll have people that'll give me x squared plus 9. They squared the first term, they squared the second term, but that's actually incorrect. That is not the way multiplication works with binomials. Okay, if I am squaring a binomial, that's not how that works. In fact, you're far better off writing that out twice and then using the distribution rule that we looked at before, where we'll take this x, this first term, and distribute it to both terms, and then take the 3 and distribute it to both terms. So we get x times x is x squared, plus x times 3 is 3x, plus 3 times x is 3x, plus 3 times 3 is 9. And so now we get x squared plus, and then we add the two like terms together. We get 6x plus 9. That's the expression that we were looking for. You need to remember to include that middle term there. Okay, that's 6x. Now, for this next one here, perimeter and area are going to be a slightly more complicated because the piece is L-shaped. And not only that, but like some of the sides here aren't given to us. We're going to do a little bit of work here. Now, notice, and I can do this a couple of different ways here, but if I drop a little line straight up like this, okay, I can break this thing into two rectangles. I can break it into this one right here and this one right here. Now, this is not the only way I could have done this, for sure. There are other ways I could have done this. Now, this length right here is going to be this top side here, 3x plus 4, minus this little bit right here. So this is going to be 3x plus 4 minus x, or 2x plus 4. Okay, that is the length of this side right here. Now, on the other hand, this little distance right here is going to be this side, 2x minus 1, minus this side right here. Okay, and just think about it, because 2x minus 1 is the total length. This is this little piece here. So what I'm looking for is this little bit that's left over. So this is going to be 2x minus 1 minus x. And that's just going to be x minus 1. So here is the length of that little green side. This over here is the length of that blue side. Now let's go back and we're going to talk about perimeter. Perimeter is the distance all the way around. Now in this case, what we're looking at isn't just a rectangle or a square. It's slightly more complicated. So what I'm going to do is I'm just going to list off the sides here. So it's going to be 3x plus 4 plus x plus 2x plus 4 plus x minus 1 plus x plus 2x minus 1. And so by doing that, I have taken into account every side around this shape here. Now, there's going to be some of you that are going to look at this and say, well, wait a minute, isn't there a way that I could have done that that's a little bit shorter? And yeah, there is. And I'll talk about that in just a moment here. But just to finish this off here, I've got 3x plus x is 4x, plus 2x is 6x, plus x is 7, plus x is 8, 2 more x is 10. So it's going to be 10x, okay, because I'm adding together like terms. So I'm adding together the terms with the x's. So just add the coefficients. Then I've got 4 as a constant here. And I slide along here, then I got a minus 1 and another minus 1. So 4 minus 1 minus 1 is going to be plus 2. So 10x plus 2. That's the perimeter. If I want to get the area, what I would do here is I'm going to do the length times width plus length times width. So for this rectangle right here, my length is going to be 2x plus 4, and my width is x. For this rectangle right here, okay, the length is 2x minus 1, but the width is also x. And so I'm going to distribute that x through, and I'll get 2x squared plus 4x. Distribute the x through, 2x squared minus x. And so altogether, I've got 4x squared terms. Okay, well, not terms, but 4 times x squared, 2 of them, and then 2 of them. And then 4x minus x is just going to be 3x. And so there's my area. Now, another way that we could have done this, though, is to have noticed this. I could have taken this side right here and slid it down. I could have taken this side right here, actually, we have a different line here, and slid it over here to make a rectangle. In which case, it would have been 3x plus 4 is the length, 2x minus 1 is the width. And so what I could have done now this doesn't work necessarily like this to find the area, but this is a little bit of a shortcut for finding the perimeter. The perimeter then could have been 2 times 3x plus 4 plus 2 times 2x minus 1. See, by moving those two sides out to create that rectangle, I don't actually change the perimeter. I don't actually change the distance around. I just change kind of the directions that I go around. as I walk around this. So this is going to become 6x plus 8 plus 4x minus 2. Oh, I think I might have done something wrong over here. So that's going to be 10x plus 6. Okay, so which makes me think up here, I might have done something wrong up here. Oh my goodness, I forgot the extra 4. Well, I'm glad I did that extra example here because, yeah, this right here is incorrect. That's my mistake here. So I forgot. I did not actually even see, okay, that extra. Whoops. No, I wanted the eraser there, and now I didn't get it. Uh-oh. This isn't going to give me the opportunity to erase that. Okay, so I'm going to have to go over top of this. So this should have been, and let's go change this. Oh wow, this is giving me all sorts of grief here right now. I'm sorry, everybody. This is going to be 10x plus 8 minus 2 plus 6. So it still does work. Okay, it's just again my mistake here. I forgot to add that extra 4 in there. Okay, now let's move on to the next question here. So the next question we have here is the length of the rectangle is 3a plus 11. So let's write that in here. So 3a plus 11, and its width is 4b plus 18. Okay. Now, my perimeter is going to be 2 times the length plus 2 times the width here. So that's going to be 2 times 3a plus 11 plus 2 times 4b plus 18. Okay, so now we're just going to do the math here. This is going to be 6a plus 22 because I have to distribute that 2 through, plus 8b plus 36 because, again, I have to distribute the 2 through. Now, adding together like terms, I am going to get, well, there is no other a, so 6a sits by itself. There is no other b, so 8b sits by itself, but 22 plus 36 is going to be 58. Now the question goes one step further. The question says, okay, that a should be 2 and b should be equal to 3. So now for us, what that means is we're going to do a substitution. I'm going to replace a with 2, and I'm going to replace b with 3. So that's going to be 12, 24, and then we've got the 58 there. Didn't do anything with the 58. And altogether, that's going to give me 94. Okay, so 94 units. I don't really have any other way of saying it. We weren't given any kind of units there. So just 94 units is going to be our perimeter. Okay, now let's take a look at a slightly more complicated area question. So this one right here, we're going to find the area of the shaded region. Now, the area of the shaded region is going to be the area here. It's already started to be shaded blue here. So it's going to be this area. And then what we're going to do is we're going to go through and we're going to erase that little bit right in there, right? So we're going to remove it there. So we are going to figure out this area here. We'll call this area 1. We're going to figure out this area right here. So the area of our shaded region is going to be the larger area minus the smaller area. So our larger area, its length and width will be 3x plus 2 multiplied by x minus 4 minus 2x multiplied by x plus 1. So that's the length times width here. Length times width of the larger one, length times width of the smaller one. So here we go. Now it's just distribution. Now, bear in mind the order of operations. I've got some multiplication going on here, and I've got some subtraction. So I'm going to do the multiplication first, but because subtraction has the ability to change terms, I'm going to put parentheses in. So my 3x plus 2 multiplied by x minus 4 is going to be 3x squared when I do the outer terms, the first terms, minus 12x when I do the outer terms here, plus 2x when I do the inner terms, and minus 8 when I do the last terms. Minus, and then I'm going to distribute that 2x through. It's going to be 2x squared plus 2x. Now, bear in mind, what I multiplied through there was a positive 2x. I put through the positive 2x. I left the subtraction on the outside here. So dropping the parentheses here and adding like terms, I get 3x squared. Well, minus 12 plus 2 is going to be minus 10x minus 8. Then I'm going to distribute the the negative through. Okay, so both those terms become negative. And now I add together the like terms. I've got 3x squared minus 2x squared. That's going to be x squared. Negative 10x minus 2x is going to be negative 12x. And then I've only got the one constant, that negative 8. So it just kind of sits there. And this is going to be x squared minus 12x minus 8 units squared, whatever those units happen to be for this particular question. So yeah, just a few application questions where we're using polynomials to talk about area and perimeter a little bit.